All right, we are going to use our graphing calculator to calculate the mean and the variance of a discrete random variable on our calculator. These are ones where you have two lists of data. In this case, we have the number of balls and we have the probability of choosing that ball. So we are going to go ahead and grab our graphing calculator. Got that. I'm going to turn it on, which is way down in the bottom. And we have our graphing calculator. I'm just going to clear out that screen. We are going to use the stat function. So we have to put our list of data in there. So we're going to find the one that says stat. We're going to do number 1 to edit. And then we're going to put our data in there. So under list 1, we're going to do the number of balls, the 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Under list 2, we are going to put the probabilities. All of our probabilities are 1/5. You don't have a fraction button on these calculators. So to do 1/5, you're going to do 1 divided by 5. 1 divided by 5 then calculates out, puts the 0.2 in there. Go ahead and do that for the rest of your values. 1 divided by 5, 1 divided by 5, 1 divided by 5, 1 divided by 5. So we have all our values in list 1 and list 2 from our table. What we're going to do is put some formulas into that table. And so it tells you that under list 3, you are going to go over here, cursor over to list 3, highlight list 3, and then we're going to put a formula in there. The formula that we want to put in there is that we want to take list 1 multiplied by list 2. So to get the list 1, the second button, and then number 1, you can see number 1, the L1 is above it. So second function 1 does L1. We're then going to multiply it, so times second function number 2 to do L2. And you can see down at the bottom, the formula there says L1 times L2. When I hit enter, it's going to fill in all of those values multiplied together. Also says we're going to put a formula in list 4. In list 4, we are going to enter the formula list 1 squared multiplied by list 2. So you can see I have list 4 highlighted. It's up there in black. I put my cursor all the way to the top. Again, I'm going to hit shift 1 to put L1 in there. I want to square it, so now I'm going to hit my x squared button, and then I want it times list 2, so shift and 2. You can then see there in the bar that I have L1 squared times L2. If I hit enter, puts all those values in my table. So we have those in there. It tells us now that we are going to type the second function and mode to quit. So I'm going to hit second and the mode button, take me back to the home screen. And if there's anything on there, you can clear it out, but if not, we are ready to go to the next step. Then it tells us we are going to do second list, hitting the stat button. You'll notice above the word stat there is the word list. And so when we hit second stat, we get the list, and we want to do the math option. So we're going to cursor over to math, and we are going to do the sum. So I'm going to pick 5. It puts in the formula, I want to do the sum of what? Well, what I want to do the sum of is sum of list 3. So I'm going to do second function and hit the number 3. Close my parenthesis on that. It's going to do the sum of list 3. If I enter, the sum of list 3 is 4. That ends up being the mean of your data. So 4 would be the answer to what the mean is. Now to do the variance, you actually have to take the sum of list 4 minus the mean squared. So now we have to do the sum of list 4. Instead of going back to your list function and math and number 5, you can just copy the entry that you had there before. To do that, you hit the second function button again, and you'll notice above the equal key is the word entry, or the enter key is the word entry. If I hit second entry, it puts what my previous entry was on my screen. I can then just cursor back, highlight list 3, and then do second 4 and change it to list 4. So now when I hit enter, it's going to do the sum of list 4, which is 24. Now in order to find the variance, we actually have to do the calculation. The calculation to find the variance is to subtract the sum of list 4 minus the mean squared. So basically I'm just going to take 24 minus 4 squared. And if I hit enter, it tells me my variance is 8. Now we could have also found that information by using the stat function and have it do our calculating. We've put our data into list 1 and list 2. If I hit stat, just the stat without the shift, and go to calculate instead of edit, we can do our 2 variable statistics. So if I choose choice number 2 for 2 variable statistics, what I would want to have entered in there is that my x variable list is list 1, my y variable list is list 2. If they're not there, second function 1 does list 1, second function 2 does list 2. We don't have a frequency list, so we can just cursor down to calculate. When we hit calculate, it gives us our 2 variable statistics. You can see the top one, x bar, is your mean. Your mean is 4, which is what we got for our mean when we did our other calculation. In order to find the variation is the population standard deviation squared. And so we would have to do our standard deviation. Our standard deviation, you will see, is the 2.8284, so forth and so on. We would have to take that value and square it. I'm just going to round off my standard deviation to 2.83. I would do second and quit to go back to the home page. And if I put in 2.83 and I go ahead and square it, 2.83 squared, hit enter, you can see that you get 8.0089. If we round that off, my variance is 8, which is the same answer we got for our variance when we did the previous table. I'm going to have you go ahead and try it for the next problem. All right, on the next problem, we're going to use our graphing calculator to do binomial random variable and find the probability of getting each value. But before we do that, I want to point out that when we did our notes and in the book, there was a table that we had to look at. So if I go ahead and go into statistics here on Alex, and I go to the textbook, if I go up to the main menu and I go down to textbook and go to the ebook, it brings up the ebook of the textbook. I'm going to bring that over here. You'll notice there's a table B. Table B is what we use to find the binomial distribution. I only used part of the table. I didn't put all of it in there. But if you're in the textbook or if you're on the ebook, if you keep scrolling, that table keeps going for quite a few pages. And so on this problem that we're going to do, the example is that we have 20 samples. We want to know if we're going to get 5 if our probability is 0.05. And so we would look for the table that has 20, if I keep scrolling, for my n value. So right here's n is 20. It's kind of small. If you click on it, you can blow it up and make it a little bigger. If n is 20 and I want to get 5, my probability is 0.002. 25, 0.002. Again, this is in your back of the book. It's table B. That's how it did it in the notes, is they had you look up the value in the table. Well, we can also use the graphing calculator in order to get that value. So I'm going to grab my calculator here and turn her on and clear it out. So I've got my calculator here, and what we're going to do is a binomial distribution. To get to that, you have to use the distribution menu, and the distribution menu is above the VARS key. So if you look at your calculator, find the key that's underneath the circle thing that says VARS. You'll notice in blue is the distribution menu. So if you hit second function, your blue key, and then the VARS button, it's going to give you the distribution menu. You can see up at the top it says distribution. We actually have to scroll down to A, so we have to scroll a little ways. You will see A says binomial distribution PDF. We're finding the probability on our binomial distribution. Now, instead of having to type the values in like you used to have to on the older calculators, when you hit enter there, it's going to prompt you for the information so you can paste it into the formula. So I'm going to hit enter. And on this one, we have 20 trials. So I'm going to put 20. Our probability was the 0.05. We have a 5% probability. We want to find the probability of getting the 5. And so we are going to enter there. I'm going to paste it in there. And so now it put it into your formula. You don't have to type it into the formula like you used to have to. And if I hit enter, you can see that I get 0.002244646. Now on the table, they rounded it off to 3 decimal places, but if you were doing a cumulative probability, you wouldn't want to round it off too early or you might get rounding errors. So your calculator is going to give you a more accurate number than using the table. So if I go to the next one, for example, if I wanted to find the cumulative probability up to 3, what I could do basically is use that same formula, but instead of just putting a 5 in there, I'm going to put in a 0, 1, 2, 3 so that I can find each of my probabilities, and then I'm going to add them up. So I'm going to go ahead again and repeat that process to get my formula in there. Second function, the vars key to get the distribution. Once I have my distribution menu, I'm going to cursor down to A, which is my binomial one. I'm going to enter on that. Again, we're going to have 20 trials. Our probability is 5%, but this is where we have to do things a little bit different. We have to put our list in braces. The braces are above the parenthesis key. So you have to hit the blue button, the second button, and parenthesis. So second parenthesis, and then I'm going to put my values in with a comma in between. The comma is above the number 7 if you look right above there. So I'm going to type in 0, 1, 2, 3. And then once I have my numbers in there, I have to close my braces. So again, the second function button, and then close my parenthesis. And you can see that my x values are now in braces. So when I hit paste in there, it's going to paste that into the formula. And you can see there that we have the formula for the binomial distribution with 20 samples, 5% probability, and then I'm going to do 0, 1, 2, and 3. When I enter, it's going to give me the list of probabilities in braces. To see the end ones, I'm going to arrow over. I'm not going to cursor up to them. I'm just going to stay underneath there, but I can cursor. So if I'm going to do my cumulative probability, I don't want to round those off too far, so I'm going to carry them out to 5 decimal places. So for example, for the 0, I would use 0.3584, and then I'd have to round that to a 9. That's my first one, which was 0. If I slide over, my probability of getting 1, 0.37735. If I cursor over, my probability of getting 2, 0.18868. I'd round that off to. And 3, 0.5958. So I would have all of my numbers, I would write them down, and then I'd add them together. So go ahead, add those together. Once you add your 4 numbers together, round them off to 3 decimal places and see what you get for your value. We are then going to find the cumulative probability without having to write them down and to round things off, just to see if we get the same number. So to find my cumulative probability, the steps are pretty close. Instead of doing A, we're going to do B on our distribution. But first of all, we're going to go to our distribution menu. So we're going to hit the second button. We're going to hit the vars key. Once we get the distribution menu, we're going to scroll down to B, which says binomial CDF. The C is to do the cumulative. So when I enter on there, we're again going to do 20 trials. We have a sample of 20. Our probability, 0.05. Here, we are just going to put the ending value. Since you're doing a cumulative one, it wants to know the cumulative up to what number. And so we're going up to 3. So we don't have to put a big long list in there. We just say what the last one is. 0, 1, 2, and 3 would be up to 3. We're going to paste that into our formula. And you can see on my screen that I have the binomial CDF 20, 0.05, 3. When I hit enter, I get 0.984 if I round that off to 3 decimal places, which should match your previous answer when we added up our cumulative probabilities the long way. Go ahead and try this on the next example. Now, we can also construct our binomial probability table. If you look again, I have my table up from the book for the number of 20 samples. So again, we're going to sample 20 people and we are going to have a 5% probability. And this time we're going to make the whole table so that we can answer multiple questions. And the first two questions are the same as the two questions we did on the previous one, and then I'll have a third one for you to try. So if I'm going to do my probability on my table, first of all, I have my graphing calculator. I have to put the numbers from 0 to 20 in my list. And so I am going to hit my Stat button. I'm going to hit 1 to edit my list. And since I've got stuff in my list, now I got to clear them out. So I'm going to cursor up to the top, clear, hit enter, cursor up on list 3, clear that, hit enter, and so forth, and clear all of my lists out of there. And then what I want to enter in for my list 1 is all of the numbers from 0 to 20. So I'm going to go ahead and do that quick. So you can now see that under list 1, if I go up to the top, I've started with 0 and I've got all the numbers down to 20 typed in my list 1. So first thing you want to do is do your numbers, how many samples, 0 to how many you have in your sample, in this case 20. So moving over to list 2, I'm going to cursor up to the top of list 2 so that L2 is highlighted. And then I'm going to put the formula in there to do that binomial distribution. So I'm going to do the same steps that I did when I did the single ones, only I'm putting it into list 2. So I'm going to hit second function, the blue button, the vars key to get the distribution menu, and then I'm going to cursor down to A, my binomial PDF one, so I put that one in there. I'm going to enter. Number of trials. We want to do 20 trials. The p-value, percent, 0.05 again. And this time for our x value, we're going to do the whole entire list. So our x values are going to be the numbers from list 1. So I'm going to hit second function 1 to get list 1 in there. And then I'm going to paste that into my formula. Now you can see on the bottom there that in list 2 I have the binomial PDF 20.05 list 1. When I enter, it's going to put all the values in there that I had for my probabilities for 0, 1, 2, 3, 4, and all the way up to 20. Now you'll notice on the table on table B on the computer screen here, they only have the probabilities up to 5, because once you get to 6, if I go to 6 here, it's in scientific notation. 6 says that you have 3 times 10 to the negative 4. Well, that would be 0.0003, and when I round that off to 3 decimal places, it just ends up being 0. And that's why the table in the book doesn't put a value there, because to 3 decimal places, my value is 0. I really do have a value. It's just really, really, really super small because it's in scientific notation and would have a bunch of zeros in front of it. So again, if I wanted to do exactly 5 people, I'm going to scroll down to 5 on here, and you can see that exactly 5 people, when I have that highlighted, is the 0.0022, and just like here on the screen for the computer, for 5 it was 0.002, and they rounded it off. So I get the exact same value I had before. Same thing if I'm doing at most 3 people. If I'm doing at most 3 people, I'm adding the 0, 1, 2, and 3. Again, you'd want to carry those numbers to 5 decimal places so that you don't get rounding errors. But for 0, you have 0.35849. For 1, 0.37735, and so forth. And so if you took 0, 1, 2, and 3 and wrote your 5 numbers or your 4 numbers down, added them together and round them off to 3 decimal places, you should get your 0.984 like we got before on the previous page. So the last one I'm going to have you do is when you have at least 3 people. If I'm going to do at least 3 people, I would have to do 4, 5, 6, 7, 8, 9, 10, all the way up to 20. And I have all those really small decimals. So instead of doing from 4 up, we can do the complement and take 1 minus 0, 1, and 2. Actually, I would have to do it 3 up because at least 3 people would include the 3. So instead of doing 3, 4, 5, 6 all the way up to 20, I can do 1 minus 0, 1, and 2. So what I'm going to have you do, again, is write down the probability for 0 to 5 decimal places, 1 5 decimal places, and 2 5 decimal places. Add those together, and then take 1 minus that answer. Then round it off to 3 decimal places to figure out what your probability that there are at least 3 people when you do your sample. Okay, now we're going to do the same thing. We're going to create a binomial distribution and a graph on Excel instead of on our calculator, in case you would want to print it out or have it handy for reference or something like that. So in Excel, I have just a blank notebook opened. They're going to have you put some labels up here. So for the A column, we're going to have our variable x. So I'm just going to put an x in there. For our B column, we're going to label it probability of x. So P of x is what I'm going to put in there. And then they're going to show you a way to put the numbers 0 to 20 in there without having to type in 0, 1, 2, 3, 4, all the way up to 20. So you could go ahead and just type in the numbers 0 to 20 in column A there, but they're going to show you a way that you can go ahead and do it and have the computer put it in there. So what they're going to have you do first of all is go up to the data tab up here where it says data. I'm going to click on that. I'm going to do data analysis. So I'm going to go over here to the right hand side, click on data analysis. And in the data analysis, we want to find the option that says random number generator. So random number generation, I guess it says, random number generation. I'm going to hit OK there. So here we have just one variable. Our one variable is the X column. We are not going to put anything in the number of random numbers. Just leave that one blank. We're going to change our distribution so that it's a pattern distribution, because we want the pattern just to go 0, 1, 2, 3, and keep going up by 1. So our parameters, we're going to start with the number 0, we're going to go up to the number 20, and we're going to go in steps of 1. Each time it's going to go up by 1. We're going to repeat each number only 1 time, and we're going to repeat the sequence 1 time. Whoops, I don't want 11, I just want a 1 in there. So the number of variables is 1. This is blank, patterned from 0 to 20, repeating steps of 1, repeating each number once, and the sequence once. We want to put the output range over here in column A. So I'm going to go from cell A2, and oops, I got to click in my little box here, cell A2, and I want to go down to cell A21, one more than the number that I want in there. So if I was going to go to 50, I would go to 51. So 0 to 21. And then I am going to go ahead and hit OK. And you will see that it filled in that with the numbers from 0 to 20. Like I said, you could have just typed that in there, but instead we just had the computer generate those numbers, because if you were going up to 100, you wouldn't want to have to type up to 100. Now we're going to find our binomial distribution. Now, one way to find it is just to type in the name while you're doing it. So if I'm in cell B2, I can just type in the equal sign, and then I can start typing in the name, B-I-N-O-M, and you can see it narrows it down here. So I want to do the binomial distribution option. I'm just going to go ahead and double click on that so that it brings it up here, but I still need to type my numbers in. So the number from my sample is that I'm going to use 0 because I'm in the 0. I'm going to put a comma. I have 20 in my sample, so the number of trials is 20. I'm going to put a comma there, and then I'm going to put my percent. My percent is going to be 0.05. I'm going to put a comma again, And then the last thing is asking, do you want to do the cumulative one? Well, we don't want to do the cumulative one, so we're going to do the false there. I'm going to go ahead and just click on false. I had to double click on the false. I could also just type the word false in there. I'm going to close my parenthesis, and when I hit enter, it gives me the probability of 0. I'm going to slide this down a little bit. Hopefully you can see that on the table from the book we had 0.358. Here we have 0.358486. It carries it off a few more decimal places. Here it rounded to 3. Here we've got a few more decimal places. Now, you could have also used the insert function thing on here. If I have my formula tab and I go to insert function, I have this table over here where I can change it to statistical functions. And in that list of statistical functions, I also have the binomial distribution. And then it gives me to fill in the options. Here for 1, or because I'm over here doing 1, I would put in 1 for my sample, my number of trials 20, my probability 0.05, and then again my logic, I'm going to do false. And if I hit OK there, it pastes it in. You can see up here at the top the formula that I would have. So I can either just type it in with the equal in front of it, or I can do the formulas and insert my function. I want that all the way down. Unfortunately, if I just do a fill down, it doesn't change my numbers. I want everything the same except for the first number should change. So what I'm going to do is just copy and paste. So I'm going to select this one. I'm going to hit Control C to copy, Control V to paste, and then just keep clicking down and copying and pasting and putting your formula in all the way down. I'm going to do that quick here. Once I get them in there, I need to change the first value. Here my first value was 0. Here my first value was 1. Here I want my first value to be 2. So I'm just going to click up here, backspace, change that to 2, and then when I put that in there, you can see it changed the value and so forth. So what you need to do then is go down your whole list, change each of those first values so they match the X value for that row. And so I'm going to go in there and keep changing my values. And I'm going to pause it for a minute here because you don't want to have to sit me watch and change all those, but go ahead and change those while I'm changing mine. All right, I have gone through and I have changed all of my first values so that I have 0, 1, 2, 3, 4, 5, 6. Whoops, the 5 didn't get in there. I better fix the 5. 5. Oops. There we go. 5, 6. Good thing to double check. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now it looks like I have them all in there. Again, if I slide this over a little bit, you can compare. You can see that you get the same values just to farther decimal places that you did on the table from the book here on Excel. And so we've got all our probabilities in there. Now, if I would want to do the cumulative probability, so I'm going to go over here and I'm going to do C of X for my cumulative probability. So the cumulative probability, same kind of thing. You could either just type in equals and start typing in the thing, or we can go up to the formula, we can insert the function, and make sure that this is under statistical. If it's not, it should be from when we looked before, but if it's not, go to statistical, cursor down to the cumulative, oh, I don't have to do the cumulative. I have to do my binomial distribution. I better do the right thing. So I have to go to my binomial distribution, which is here. And instead of saying false, I'm going to say true. So doing that same binomial distribution I did here, I'm going to hit OK. My sample number is 0. The number of trials was 20. The probability was 0.05. But instead of saying false here, I'm going to say true there. And then I can hit OK there. So the true will give me the cumulative. False gave me just the single probability. Now the cumulative one here is the same because I just started at 0. What I'm going to do is I'm going to go ahead and copy and paste that formula. Control C, Control V to paste. And then again change my front number from 0 to 1. So if I put a 1 there instead, you can see then it added those two probabilities together and gave me my cumulative probability. Again, I have to put that all the way down, and the fill down doesn't work very well, so I'm just going to Control C and I'm going to Control V to paste it in there, and I'm going to paste it in for all of them quickly, just using my arrow key to go down so I can put them in pretty quickly. And then again I have to go up once I get them all in and edit the front number so it matches the number in that row for the X value. So instead of the 1, I want to have a 2, and then enter that in there, and then same thing, I'm going to make that 3 and enter. And so again, I'm going to pause the video, fill that in. You go ahead and fill yours in as we go here. All right, I've got my values typed in there. Again, if I go and check my formulas, the first number should match my X value. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I didn't get 9 on 9. See, good thing I double checked. Whoops, backspace. I put my 9 in there. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Got all my front numbers changed to match my values. I now have the cumulative. So if I would want to know what the cumulative up to 3 is, that's the one we did on our paper. You can see I get 0.984 when I round that off to 3 decimal places, and there's my cumulative probability. Now, one other thing that you might wish to do is to make a table from your graph. And so what I'm going to do is I'm going to make a table of the probabilities. So I'm going to go ahead and highlight this column, select that data. I am going to go to the insert function up at the top, and I am going to insert the bar, column or bar chart. So if I go to column or bar chart, I'm going to click the drop down arrow and I'm going to choose that first 2D column. So I'm going to have my chart. Now on this chart, just a couple things we need to fix. You notice down at the bottom it goes from 1 to 21, and we actually want it to go from 0 to 20. So we're going to right click on the chart like we did before when we did charts. We're going to select our data. Select the data. We're going to edit the horizontal category. So I'm going to hit edit, and then I'm going to highlight from 0 to 20, that first row there, or column. Hit OK, and hit OK again. You can see now that it's labeled from 0 to 20. Again, these values over here past 6 are rounded off to 0. They're so small they're not going to show up on your chart. You might also want to change your chart title so you know what you did. So I'm going to go up to chart title. I'm going to type in that I did a binomial distribution. Where n was equal to 20 and p was equal to 0.05. And now I have that. When I graph that, you noticed I moved my table over. I'm going to go up to File. I'm going to print that out. When I print it, oh, I had my chart selected, so that would only show my chart. So I better go back, unselect my chart. Now I don't have my chart selected. I'm going to go to File. I'm going to go to Print. And again, instead of being in portrait, you probably want to switch it to landscape. And so now I have all my information there, and I can go ahead and print out my table with my graph. I'm going to again have you go ahead, and I'm going to turn this off, and I'm going to have you try the next one with different information. All right, we are going to go back to our calculators and do some of those extra different kinds of distributions. In the brief version of the book, they don't cover that, but in the full version of the book which we have on Alex, they do talk about that, although we're not going to do a whole lot of problems. But just in the event that you would want to do some of these calculations, you can either do them on your graphing calculator, and some of them you can do on Excel. So the first one is the Poisson random variable one. Nice French word. To find the probability for your Poisson random variable, again, we are going to use that distribution menu. So we're going to use the second vars key. So the example problem says, if there are 200 typographical errors randomly distributed in a 500-page manuscript, find the probability that a given page contains exactly 3 errors. So I am going to grab my graphing calculator. I got it turned on. Second function, quit to go back to my home screen. So my home screen is there and it's blank. Again, I'm going to hit the second button and the vars key to get my distribution menu. Oops. All right, so I have my distribution menu, and I am going to scroll down to choice C this time. So if I scroll down, you will see that you have the Poisson PDF, the probability distribution for that function. And so I am going to go ahead and enter on that. Again, it's going to prompt me for the information. Now the first one is the symbol for the percentage. Now you can either enter in the fraction or the decimal. I'm going to do it both ways just so you can see I get the same answer. It said there in the word problem that there were 200 typographical errors in a 500-page manuscript. So I am going to put in 200 divided by 500 and use the fraction there. My value there, we wanted to know that there was exactly 3 errors. So I'm going to put 3. I'm going to paste that into my formula. You can see that I have the Poisson PDF, the fraction 200 out of 500, and I want to find exactly 3. If I hit enter, I get 0.007 if I round that off to 3 decimal places. Now I could have also used the percent there. Again, if I hit second function, my distribution menu, go down to C. Whoop. Try that again. Second function, distribution, go down to C. And hit enter there. Instead of using the 200 out of 500, if you calculate that, you get 40%, 0.4 or 0.40, or however you want to type that in there. Enter it in, paste it into my formula, and when I hit enter, you can see I got the same answer either way. So I can either enter it in as the fraction, or I can convert it to the decimal and put the decimal in there. Now the next example there says a sales firm receives on average 3 calls per hour for any given hour. Find the probability that it will receive at most 3 calls. So again, I am going to do my Poisson distribution, but since I'm doing at most 3, I'm going to do that list, and I have to put my list in braces. So I'm going to hit second function, hit the distribution to get my distribution menu. Again, I'm going to go down to C and hit enter there. So on this one, when we enter in our information, we are going to use 3 because it says that they get 3 calls per hour. So I'm going to put my 3 in there, 3 calls an hour. My X value here, I'm going to put in braces because again, I'm going to do at most, and so I am going to put in 0, 1, 2, and 3. So in braces, second function, and then the parenthesis button, 0, comma, 1, comma, 2, comma, 3, second function parenthesis. So my X value is in that list, and whenever I do that list, I have to put my list in braces. And then when I go ahead and paste that into the formula, you can see there that it has it in braces. When I enter, again, it's going to give me the list for 0, for 1, for 2, for 3. Carry each of those out to 4 to 5 decimal places, and then total them up to see what your total probability would be for at most 3 calls. And on your at most 3 calls, go ahead and round it off to 3 decimal places. So again, to check your information, you're just going to cursor over, write them down to 4 or 5 decimal places so that you don't get rounding errors, and then add them up and find your total. The next one you're going to do then, instead of having to add them separately like we did before, we're going to go ahead and just do the cumulative one. So for the cumulative one, we're going to do D instead of C. So again, we're going to hit our second function. We're going to go to the vars menu, for the distribution menu. We're going to cursor all the way down to D. You'll see D is the Poisson distribution. It's a CDF to do the cumulative distribution. And so I'm going to enter there. Again, the probability or the average was 3 calls per hour. So we're going to put a 3 in there. We're going to put in 3 for our X value because again, we want to do at most 3 calls. And so our top number is going to be 3. And then we're going to paste that into the formula. Once I get that in there, let's see if I can get this to focus a little better. Paste that in. And you can see there that we have our distribution 3, 3, and when I enter, I should get the value that I got when I added my number singly together, rounding off to 3 decimal places. 0.647 would be my answer, and so I should have that for the answer for at most 3 calls when I did it the long way and added my numbers together. And again, when I do the cumulative one on the calculator, I should get the exact same answer, which I do. All right, now we're going to use Excel to calculate some of those other discrete distributions. The first one we're going to do is a hypergeometric one. And so, for example, 10 people are applying for a job as assistant manager of a restaurant. 5 have completed college and 5 have not. The manager selects 3 applicants at random. Find the probability that all 3 are college graduates. So in Excel, we are going to again do a function. We could hit equal and start typing in the name of the function, or we can go to our formulas menu, formulas, insert function over here. Again, we want to make sure that the category is statistical. If not, we're going to change that to statistical. And we're going to find the hypergeometric one. So I'm going to go down to the H's. Hypergeometric distribution right there. I'm going to select that. I'm going to hit OK, and it's going to prompt me for the information that I'm going to put in there. So for my sample, I am going to he's going to select 3 applicants. So I'm going to put 3 for my sample. And then for the number of sample, the sample size, we're also going to put 3 in there. Whoop. Next one down. The population, S, is the number of successes in the population. 5 were college graduates. The number population is 10. There were 10 people applying for a job. 5 completed college, 5 did not. We don't want to do the cumulative, so we are going to hit false and put false in there instead of true in there because we're just calculating the probability for this one event. So the probability that all 3 are college graduates, if I hit OK, puts it up here. It says round it to 4 decimal places, so we got 0.0833 when I round that off. Another probability we could do, I'm just going to go over here in this next spot over here in C, and we're going to do a Poisson probability like we did on the previous problem. And so again, we could start typing in the name equal and then the name of the formula, or we can just go up to formulas again, insert function. Again, this needs to be on statistical, and then I'm going to scroll down to the P's. I'm going to grab my thing and go a little faster. But there's the Poisson distribution right there. I'm going to click on that, hit OK. It's going to prompt me for the for the values that go in there. So we have 2% of the people in a room of 200 people are left-handed. Find the probability that exactly 5 are left-handed. So 5 is going to be our X value. The mean or the average was that 2% of 200. We could calculate that out and put the number in there, or we could just put the formula in there. So I'm just going to put 0.02 times 200 in there, and it's going to figure out that the answer is 4. You could have figured it out ahead of time and typed the 4 in there. And again, we don't want to do the cumulative, so we're going to put false. And I am going to hit enter, and there is going to be my probability then that exactly 5 people are left-handed. Again, go ahead and round that off to 4 decimal places. And then there's also a geometric probability. There is not a built-in geometric probability distribution function, so we have to do the negative binomial one and figure out how many failures instead of successes. And so I'm going to go over here in column E, and we're going to go ahead and compute that. The example says in the U.S. approximately 42% of the people have type A blood. If 4 people are selected at random, find the probability that the 4th person is the one that's selected with type A blood. Again, we're going to do a formula, so I'm going to go up to formula. I'm going to insert function, and because there is not a geometric probability function, I'm going to look for the negative binomial one. So I'm going to go down to the ends. There is the negative binomial distribution. That's the one we're going to use. I'm going to hit OK. And so we have to fill in our values here. And so for the number F, we're going to put in 3 for our number of failures. The reason we are using 3 there is because we have type A, type B, type O, and type AB. We have 4 blood types. We're going to have 3 failures to get 1 success. I only want type A, but I'm typing in the number of failures, which would be 3. The number of successes would be 1. Type A blood, I got 1 choice there. The probability was 42%, so I'm going to type in the 0.42, my percent as a decimal. And again, I don't want to do the cumulative value, so I'm just going to put false in there. And so if I hit OK on that, that's going to give me my probability that the 4th person is the first one that has type A blood. The other previous 3 people would have some other kind of blood other than type A. Go ahead, write your answer down to 4 decimal places, and that is the end of our technology activity for Chapter 5.